The geometry features considered in this section include basic components that guide horizontal and vertical alignments, including curvature and width, and elements that form the cross section of the highway, including lanes, shoulders, and medians. So intersections and interchanges are important parts of highway design due to their significant impact on safety performance and operational efficiency. So we will talk about the intersections and interchanges. They are important parts of the highway design. We indirect design factors. Indirect design factors are essential components that guide the selection of dimensional design values, but are not directly implemented in construction of the highway. The indirect design factors include these: design year. Design year is 设计年限啊 functional plus access control, design vehicle, design driver, user capacity, design speed. These are indirect design factors. Design year. Design year has important implications on the design of a highway, particularly in the anticipation of future conditions and the ability of the highway to efficiently and safely process the demand. For large projects, design year is commonly 20 to 30 years
in the future.
But for asphalt pavement, the design year is commonly 15 years. But for concrete, cement concrete asphalt, cement concrete pavement is 30 years. So for different projects, the design year is different. But for large projects, the design year is commonly 20 to 30 years into the future. Predicting future demand is a difficult process, and a well-developed future demand can inform the design process to reduce the risk of under or over designing the highway. So, the predicting future demand is inform design process to reduce the risk of under or over designing the highway. If we predicting future demand is less than actually, but is under or over designing the highway, if we predict the volume, traffic volume is less than the actual. Yes. So, the predicting future demand will predict actually. But how to make it actually is a difficult process. If predictions are unreliable or future demand are expected to remain constant in the near term and increase rapidly in the long term, design elements can be incorporated that will decrease future costs and construction time. These elements may include initial widening of bridges to accommodate additional names or applying necessary additional right of way for a wider facility. So these elements will include this. Functional class. The functional classification of a highway is typically identified during planning processes. During planning process, we'll identify the functional classification. And it is not at the discretion of the designer. The function of a highway has a considerable impact on design elements. So, function and a considerable impact on design elements. So, the design elements is depending on function of a highway. Especially in the framework of providing the appropriate balance of mobility and accessibility. Arterials are designed with the goal of high mobility, while local roads are designed for higher accessibility. So, different classification, function classification means has great impact on the great design elements. Access control relates to the function classification, the types of access on the road affect mobility and accessibility. Interstate highways have full control of the access to the highway, providing access to drivers only through ramps and interchanges. So, interstate highways, full control of the access. So only through ramps, access interchanges. While local and collector streets typically allow each parcel owner to directly access the road, higher speed highways may use frontage roads to connect properties to other highways. The density of access points directly impacts the safety and efficiency of the road. We can know that for local road or freeway, the access is different. Design vehicle. The design vehicle is critical for turning movements and is most influential at intersections. Large vehicles require large turning radius to accommodate turns, particularly wide turns. Large vehicles require large turning radius. Higher vertical clearance and longer segments for acceleration and deceleration. So for different vehicles, there demand different turning radius. Vertical clearance and segments are different for deceleration and acceleration. We can know that. On this table, we can get design, vehicle dimensions, design vehicle type. Design vehicle type is passenger, buses, combination trucks, and recreational vehicles. And the different height, width, and length. So for different vehicles, they all have different dimensions. The length, longest is 114 feet, and the widest is 8.5 feet. The widest is the difference of widest of different vehicles. The difference is small. It's just 7 to 8.5. The difference is 1.5 feet. But the longer the length, the difference of length is large. The height. The passenger car is 4.3 feet, but for Rocky Mountain Double Trail is 13.5. Design driver or user. The design driver is inherent in the design of a highway. When attempting to meet drivers' expectations and provide actioning information, a typical design driver is usually assumed to have slower than average information processing, reacting, and decision-making abilities. A typical design driver assumed to have slower than average information processing, reacting, decision-making abilities. So this is design, a typical design driver. These attributes apply to reaction types, signing, marking, and other human factor elements. So different driver have different reaction time for the same action, same 就是同一个事情，不同的驾驶者反应的时间和速度都不同，对吧？不同，听得懂吗？同一个人不同的人，比如说你和我，对吧？对同一个事情，都驾车去同一个地方，碰到同一个事情，反应的速度和时间都是不一样的。Okay? So the reaction time, signing, and marking are different. Similarly, non-motorized users such as pedestrians and bicyclists may require special considerations in the design of a roadway, particularly at crossing locations or intersections, such as sidewalkers, bicycle lanes, median refuge islands, accessibility components for persons with disabilities. and so on. What is refuge island? Median refuge island. Median refuge island.
The line in the middle of the road.
Yes.
Trees.
Yes, trees to make the walkers or bicycles to stop.
Yeah.
Capacity. The capacity of the highway and other related operational measures are essential to consider when developing design characteristics for a specific highway. The capacity will affect critical design features, including the number of through lanes, turning lanes, intersection configuration, and traffic control. So, capacity will affect critical design features. That's like the number of through lanes, turning lanes, intersection configuration, and traffic control. The level of service associated with the capacity varies depending on the setting and the functional plans. So, setting and functional capacity is determined. The level of service associated with the capacity. Design speed is selecting dimensional values for many highway components, particularly the elements related to horizontal and vertical alignment. Is the maximum safe operating speed under favorite vehicle, highway, and weather conditions. This is just design speed, weather conditions, and highway. Just for freeway in China, the design speed is how much? How many?
120.
Kilometers per hour?
120.
120.
It's a guess. We don't know if it's
Yes.
120.
120 per hour.
120 kilometers per hour is the highest. But for different freeways, they are according to the
Oh, I think he's talking about the highway.
weather, the geometric and other factors.
80 to 60.
The highway, the design speed is different, but
Yes, that is what-
the highest is 120. But for in mountains or other areas, they will slower than 120. But 100 or 80 kilometers per hour, so it is different. But we know that its maximum safety operating speed for weather conditions or for freeways, we run in the freeway The normal design speed is 120, but when we go through the tunnel, we will reduce
170,
80 or 100 kilometers per hour. The speed limit is typically 5 or 10 lower than the design speed to provide an appropriate factor of safety for drivers. Consistency in design speed along the highway is desirable for safe and efficient operations. So, consistency in design speed is desirable for safe and efficient operations, but according to different conditions, we can always, according to this, consistent in design speed. Dimensional design values. The dimensional design values are features that directly affect the size and the shape of the highway. Dimensional design values include lane wideness, shoulder wideness, bridge wideness, and horizontal alignment, shoulder elevation, vertical alignment, grade, stopping sight distance, cross slope, vertical periods, natural offset to obstruction, structural capacity. But in this, we are talking about in the上一节课我们已经讨论了，对吧？Horizontal alignment, super elevation, we talked it before. Now, let's talk about lane wideness. Lane wideness directly affect the required right of way. Right of way necessary to constructing the road. The cost of paving and repaving. Crossing distances for pedestrians, operating speeds, likelihood of collisions resulting from leaving the travel lane, and available maneuvering and turning space for larger vehicles. So lane wideness affects this aspect. One is requiring right of way necessary to construct a road, and the cost of paving and repaving, crossing distance for pedestrians, operating speed, and the likelihood of collisions resulting from leaving the travel lane, available maneuvering and turning space for large vehicles. Recommended lane wideness by road type. You know that for different road types, the lane wideness is different. For freeway, lane wideness is 12 feet. But the arterial for urban is 10 to 12. For rural is 11 to 12. For red, one lane is 12 to 30. Two lanes is 12 to 23. From this table, we know that for different type of roadway, the lane values is different. Show the values. Adequate show values can provide space for collision avoidance or errant vehicle recovery. Disable the vehicle storage, maintenance activities, enforcement, additional space for bicycles, police, or oversized vehicles. Improve the sight distance and support for travel lane pavement. So we can know that show the vitals is to provide space for this. From this table, with recommended shoulder vitals by roadway type, we can know that for freeway, the shoulder vitals is 4 to 12 feet. Local, collect, and arterial is from 2 to 8 feet. On the shoulder, according to different conditions, the shoulder vitals is different. We must to consider the actual conditions. Grade has insignificant operation and safety impact on vehicles. Operationally, vehicles, particularly heavy vehicles, will lose speed or sustain upgrade of significant lengths, and may need to descend and reduce the speed to elevate braking issues. Reduced speed from a portion of the vehicles can create a safety concern for other vehicles who may be travel faster. Additionally, if heavy vehicles are unable to control their speed on steep descents, lane departure collisions may result. For land or nearly flat graders, hydroplaning can be serious concern. What is hydroplaning?
Hydroplaning.
Yes, that's right.
水
Yeah.
It's about 水 water.
Yeah.
Hydroplaning. For flat or nearly flat graders, hydroplaning can be serious concern. Because it is flat, there is no grade. The water can drain
Drainage.
There's no water draining.
Drainage.
it. The water is flat, so the water can drainage rapidly or faster. The recommended maximum grade by roadway, level rolling, terrain type. For different terrain type, a level rolling mountains and design speed, just for level and 60 design speed, the grade is 3. For mountains is 6. Urban arterial road design speed. The terrain type is 3 times. But for mountains, 60 mph. The grade is 8. So from this table, we know that for different type of terrain, the design, the grade is different for and different design speed. Okay, we have a list. X distance from the beginning of the vertical in stations or feet. AB is coefficient defined below. Just the parameters we should determine according actual considerations. C. Elevation of the PVC. C is the PVC elevation. Because x is equal to 0 corresponds to the PVC. When we set x is equal to 0, we can get y is equal to c. Yes or no?
Yes.
Okay. We can use these formulas, function, parabolic function. We can got and the PVC x is equal to 0 and y is to c. So first derivative, the slope.
That is the slope.
We can got and the PVC x is equal to 0 and
dy
the first
dy
is to
dx is equals to b is equals to g minus 1.
is to G1. Yes or no?
Yes.
Okay. And this is the first. And the second derivative, the rate of the change of slope. We can got it everywhere. The second derivative is equal
d2y
to
over dx squared.
2 times A. We can use this relationship G2 minus G1 divided by L. And A is equal to this. Yes or no?
Yeah.
Okay. So we use this function, the parabolic function. We can, according to these conditions, to determine C, B, and A. And when we know the C, G1, G2, G1, and L, we can got A, B, C. We can get. So, we know that this general equation can be modified for each individual curve to describe the relationship between the distance x and the elevation y at any point along the vertical curve. The term x is used to denote any horizontal distance along the curve and is bounded by 0. which would
Designate.
designate a PVC point, and the length of the curve which would designate the PVT point. The term A becomes the tangent offset, the changing elevation from the tangent to the curve, and the grade of G1 replaces the term B and C becomes the elevation of the PVC. So the parabolic equation will adapt specifically in terms of vertical curves takes the following form. It's right.
We don't know. Yes.
We can know that C, G,
2. Okay.
A, B, C.
Mm.
We can go this in another form.
Mm-hmm. This is A. This is B. Then
This
that's
is
C.
A, B, C.
Oh.
So we can know from these formula or equations easily. Okay. Some additional properties of vertical curves can now be formalized. For example, offset, which are vertical distance from the initial tangent to the curve, are extremely important in vertical curve design and construction. But from this, we can know how far this offset we can get. Question why? Which is also important. Offsets for equal-tangent vertical curves. How to calculate or compute?
I should say that again.
How to calculate y or ym?
Okay.
Or compute?
Y. We have L2 and we have a bigger L. And we have X. It's what? Offset
But we should know what this means.
first. Offset.
G1, G2 is like before. Y is offset at any distance x from the PVC in feet. Ym middle curve offset in feet. And like this from PVI to the curve. X is distance from the PVC. L is the length of the curve in stations. PVC, PVI, PVT is like before. So we should know how to calculate or compute y or ym. From this, we can use this formula to calculate y, ym, and yf. But we should know that G1, G2 in percent, L in feet. A is absolute value of the difference in rate expressed in percent.
Percentage.
Like this. But this absolute value, it is when we calculate y and we should first to calculate or get A. We should know G1 and G2. Yes or no?
Yeah.
Yes. When we get A, when we should use this formula to calculate y. So x and L is we know,
Mm-hmm.
and ym is
L.
8 multiplied by L and divided by 800. This is we let x is equal to
Sorry.
L divided by 2, just like this. We can got ym. We let x is equal to this. Divided by 2.
L is X.
Let x is equal to
L divided by 2. But there's a
Let
difference.
divided by 2, we can get ym.
Huh.
Yes?
I don't get it.
Ym is
L.
when x is equal to L divided by 2 is the mid of the
Okay. But right now X is not equal to L divided by 2. Alright. When. Okay. So, Laushi, question. So, these figures 200, 800, and 200, are they fixed figures?
200.
Yes. 800, 200. Are they fixed figures?
Yes.
Or they are fixed?
Fixed.
Okay. Well,
They are fixed, so we should
know them.
change it.
Okay.
It's 200, 800, and 200. So when we know L and then G1 and G2, we can get Y, Ym, and
YF.
YF. So by setting this equation equal to 0 and substituting the vertical curve specified components for A and B, the equation for the location of the high or low point can be determined. When we use the first derivative is equal to 0, we can know the low or high point of the curve. The parabolic equation can be used to determine the elevation at this point. The high point can be identified for crest curve.
Crest curve.
Crest. And the low point can be found for sine curve. These points are never above for crest curve or below for sine curve, the PVI. Identifying and locating the high or low point of a vertical curve is important for drainage considerations. This is for drainage considerations and for determining where the appropriate clearance is provided. Appropriate clearance is provided underneath an overhead structure or on top of underground utilities. So, we should identify locating the high or low point of a vertical curve. It's important. One reason is drainage consideration, and another is the appropriate clearance. So we should consider these two aspects.
Record. 5, 4, 3,
The following
1.
process